Okay, so classes and objects. From the chapter, you may have understood some things about objects. You still may have some questions in there about things. If you have some questions, then you can hopefully get a little bit more background from today's lecture. I plan to go through some pretty in detailed pieces as far as how to read a UML, or Universal Modeling Language. That's the UML diagram. It is used to diagram classes and objects. And so we will be going through that extensively. You should be able to construct UMLs and also interpret UML material and take it and use it to create your own classes. So I will be doing a couple of examples of that. So when you define a class in Java, you're defining a new reference type. So this is one of those with, if you were doing memory stack diagram, that it would have the arrow in it. So it's the arrow pointer pieces that would have references that are pointed to. So class that we're going to look at here is die objects. We've looked at a couple of those already because of our midterm programming assignment. So some semesters we don't quite have as much of that, but this time we did for sure. And ours was pretty similar to this one as far as the construction of it. So here it is, this die object. This is the UML diagram itself. I'll give some more examples on Thursday about more about the translation of these UML diagrams. First, we start with the top section here. This top box is the name of the class. So it's the die class. That gets put over to here, this public class die. So that's how we can build that. You can take from a UML diagram, you should be able to take from a UML diagram and almost one for one construct the class itself. So you can take from this is a class die. So we're going to build that. I'm going to go ahead and do this in Eclipse too, just so that you can see a little bit more of Eclipse and get a little bit more of a feel for that as well. Again, you don't have to use Eclipse. You can use it's fine to just use JGrasp if you'd like to, but I'm going to give a couple more examples in Eclipse just so those who are going to continue to use it will have the idea of how to do things within Eclipse. So I'm going to start out here. I'm going to create a new project, Java project. I'll call it the die class. And I'm going to make sure I use project folder as root for source and class folders. We go next in here. And I'll go finish, and that's going to create the die class here. I'm going to go in here, right click, new Java class, and I'm going to call this die because that's the class I want. I'll go ahead and do this piece here and then this piece to get the main, and then this just so I have some place to test some things. All right, so it built out my die class here, and I'm going to go ahead and put in here die emulates a dice object, a die object. Let's do that, and then let's get into here, and we'll go main. I'm not going to do a whole lot around this. Let that step out like that. Okay, so inside of here, the next section inside of your UML diagram is this section that gives you the attributes. These are the items that are created with every instance or instantiation of this class. So we're going to have different objects that we create. We'll have different dice objects that we create out here. So I'll have one die object that I create here that I can then roll, and it'll have a face value for each side of the die object. So that's the kind of thing that we'll have in here. So in here, we're going to go ahead and and I like to just do a section here inside of this that says attributes and give the attributes of the class here. I'm going to go down here and I'll look in here. Most of our attributes are going to be what we call private attributes rather than public. So this is finally where we're unpacking this idea of public static void main. We're going to get to these last two items, the public and static. So public means it's available to everyone, the world, to read. Private means it's only available within the class itself. And so that's what we're going to do. We see this minus sign here, minus face colon int. So we read that and interpret that as this is a private attribute with the minus, and it is a type int, and it is a variable called face. So that's how we interpret that. Private int face, and that's going to be the one attribute that we have for this die class. And that's all we have, just the one attribute. So it's going to have a face value. It's going to be 1 through 6, an integer 1 through 6. So we could even say that in here somewhere if we wanted to, just to give it a little bit more. So that would give it an idea, us an idea of what's being stored in there and how that works. All right, so now we come into here and we're going to create what we call the constructor for the class. This tells us how a dice object is going to get created and what it's going to look like when we create it. So we're going to do some things here. I'm going to go ahead and actually do the role class first, because we're going to use that inside of our constructor. So it might be easier to have that class available. It's going to be an interesting thing. At this point, we're going to have some classes that we use other methods within the class to create an object of that class type. So here we go. We've got this role method here. Simulates a dice roll, a random dice roll. All right. Return new face value of the die. All right. And we're going to come into here, and roll over here is a public because it is a plus sign in there. So it's an int type. The colon after the colon tells us what the return type for this method is. So we can see over here, we're going to have an int type in this roll method, public int roll, and we're going to have no parameters that we're passing it. So we've got that, and then we're going to return a 0 for now, just to close that out and get it happy as far as the return and also compilation errors are concerned. Okay, so now what do we need to do with this? We're going to say, we're going to set the face of this die, and we're going to mask this as an int, and we're going to do this math.random, and we're going to times 6, whatever value we get from math.random, and then we're going to add 1 to it, because that's going to give us a number 0 through 6 here. And then we're going to add 0 through 5, and then we're going to add 1 to it. So that's going to give us a number 1 through 6. And we're going to mask that as an int, or cast that as an int, because we want to make sure that this, what is a decimal number or a double type floating point number, gets cast as an integer. So this is going to give us a random value times 6 plus 1. So we're going to have a value 1 through 6. And this is how we generate that 1 through 6 randomly. So that is what we do there. And then we return the face value here. So that's what we do with the roll in there. And that will get us a new face value here. So for our constructor, what we're going to do is just roll the die. So we're going to come into here and create the constructor. This one up here, this die. So this is, again, where there's a lot of dying here. We've got this one here where we do constructor or new die random face value. All right. And we don't really have any kind of attributes there or any other things, parameters or any of that. So public die And this is just going to say roll. So we know we're going to work with this object and we're going to roll the object. So that's what we're going to do with it. And when we roll it, we're going to get a new face value and we're going to return that. So that's what happens when we do this roll here. The last item here is the get face. So when we're working with objects, we can't just go in and get that attribute, especially if we're calling it from a separate method. If we're in the main, we can go in and get the current object's face value because we're in that method. But if we want to use that class outside of this class itself, then we need to have what we call getters or accessors, something that we can go get the values of and return the values of the attributes for that class because they're private. And we want them to be private because we don't want to be able to manipulate them outside of the class itself. Doing that leads to security issues. Some of the most common kind of hacking things that happen are because of this kind of thing where we leave things in a state where others can manipulate them, others can mess with the values, others can look at things that they shouldn't be able to look at, like passwords, for instance. Sometimes password fields are left in a way where they are publicly available. Don't ask me why somebody would do that, but it's a mistake that is made more often than not, as you can see from all the news reports of different sites getting hacked and then your password getting hacked and you having to go change your password from one of these notifications from a company that has lost your data. If the company's good, a lot of times that's an encrypted password, so it's not as bad, but still, they've lost your data and somebody could go crack that password or unencrypt or decrypt that password and then find out what your password is. So let's go ahead and go into here. So we're going to create this getter or face value. All right. And then what we've got here is we got an @return item here. We need @return. And this is going to be an int current face value of die. That there, okay. All right, and then we go public int, and we know this is an int again because we have the after the colon piece here. We've got that. We're going to go get face, and we're going to go in here, and we're just, if this is a simple method, all we're doing is returning the value of the face value. A lot of times we're going to have this dot. So the term this is going to be used a lot of times when we want to say this current object that I'm working with. I like to overuse this phrase this. I tend to do that because I like to make sure I know what object I'm working with. So I would probably write this as this dot face because I want to know that it is this die object that I'm working with and the face value of that versus that or the other. So a lot of times in our variable naming, we're going to be using this dot face, and then we'll use a variable called other, or that is what I will use so that I know it's not this, but it's that. So that's a good way to keep from confusing which die object you're working with or which face value you're working with, because it will get confusing when you start working with more objects than not. So especially as we look towards the final programming assignment. FYI, for a couple weeks from now, that assignment will be a pretty big assignment as far as the amount of code and amount of files you're going to be working with. I think you're going to have to develop 6 different files for that one. So it will be putting all of that together. So just make sure you do not snooze on that and do not start it late. it is going to be worth 5% of your grade. So overall, so it is half a letter grade. So make sure you don't just punt that assignment. I cannot stress that enough. I'm going to try and reduce the number of other things that you have to do at the time so that we can focus on that and that you can devote most of your time to that. I will only have a few lab kind of things that we may not even grade. I may not even grade those labs because I'm feeling like this assignment is a pretty big assignment and it's going to take you some time to get it done. So again, don't fall asleep on that. Don't snooze that or punt that or kick it down the curb too far, because it's going to come back to bite you if you procrastinate that and blow it off for too long. So just trying to give you some advice because it is definitely one that is going to take some time to get done. All right, so now we have a dice we can work with. So let's go ahead and go down here into the main. I die equals new die. So here's how we call this. And we just say we want a new die down here. Then what we can do is my die system.out.println. We can go my die.getFace. And we can say, and we got to put these parentheses because we've got it as a method call. Face value is, and we can go that and then put the face value. All right. Then we can do a roll. My die dot roll, and this is how we're calling that roll method inside of the die. And then we can new face value is, and then we'll do the my die dot get face. All right. So if we run this, we can now see the face value starts at 2. So we create this and it has a face value of 2. Then we roll it over here and then we get a face value of 3. So let's do this too. Let's go ahead and print out the face value to begin with before we do anything. Well, so we've just done that. Yes, so that 2 was the initial face value. So we note that there is an actual face value that gets created when we start this. And when it is created, it randomly rolls and gets assigned because this constructor over here says we want to roll it. And what it's doing is it's setting this dot face. So in the roll, it's this dot face equals that piece. And then it's returning the face value as well so that you can actually write it. So when we use the system out print line, it is writing that out too. So that is the die value here. So if we run it again, we've got a new face value. We've got a 1 and then a 6. So if we keep doing this, we're going to keep getting different random numbers in here as our output. We've got a 6 and a 4 that actually repeated once, 6 and a 3, 2 and a 2, 5 and a 2. So this is how we can write a dice program. This was how we wrote the dice program that you guys used inside of the dice roulette program. So you didn't need to know anything more about the dice class at the time because we gave you all you needed to know. And we kind of what we call hid or encapsulated it from you so that you did not know what the contents of this black box die was. But you were able to still use that object and use the results of that object when you were doing your dice roulette and testing against that. So that's often what's going to happen in the real world. If you're working on something, you may be working on one class within a giant project, and it's one piece of a huge mechanism that is doing a whole bunch of other things, and yours is just the one section that you're working on and that you've been tasked to work with. So that's not an uncommon way for programming shops and employers to do things. All right, so if we look at the attributes of the die, we can see here that those are the attributes are the face only. That's all we have. We've got the roll, the get face, and the constructor here. Those are the 3 methods that we have in here. And in the symbols minus and plus are private and public again. And then again, we're looking at and noticing how the role method refers to face, yet that variable is not declared in the method. It's being used because it's part of the class attribute, and we have that. And we can access that because we're inside of the class. So, and if we're in another class and we wanted to call the die object, we would have to do something a little bit different. So over here, we'd have to do die lucky die equals new die. So that's how that statement would look like. All right. And then again, instantiate a new object is die, my die equals new die. We've gone over that over here in the main. And then we're getting the random roll. And then if we had int value, value equals die dot get face. Over here, the problem with this code is that this die needs an object to be called. You can't call the class get face without calling the it from an object. So you have to go my die dot get face, not just die dot get face. And this is because it is not a static method. It is a non-static method. So static methods means that you can call them whether or not you have an object or not. So non-static objects can only be, or methods can only be called with an object. So you need to have an object and call it with the dot methodology. So you have to say my die dot get face because we don't have this as a static method. If you had it as a static method, you could say die.getFace, and that would be correct, actually. So this one up here in 7 would be correct if we were using it as a static method. That's why with the main, we always use it as a static method, because Java wants to actually call that main statically. It just wants to call that main wherever it's trying to do that. So it can do that because it is a static method. So static and non-static have to do with how you call a method based on whether you have an object or you don't have an object. So static means you don't need an object to call the method. Non-static means you need to have an object in order to call that method. All right. So we want to set add a method to the die class that allows us to change the face directly. So if we do this kind of thing, and we call this over here with a set face, face equals new face, and we're going to set this into here. This is a static method here and can't be called against an object. So we would need to have it be public void set face instead of that. So let's go ahead and write this. So if we wanted to be able to load the dice, and we did this for the dice class that we had for the dice roulette, because we needed to be able to test with certain dice that we set. So if we wanted to do this setter for, or mutator, that's the other word here. So it's setters and getters, mutators and accessors. So mutation, you're changing it, just like the biology kind of term. Accessor is I'm accessing it, I'm getting the value, and versus I'm setting the value. So those words are used synonymously. Getter and setter are the pair, accessor and mutator. So those are the two pairs of ways we call these things as far as object-oriented terminology and language. For die. Loads dice die with value new face. All right, that param new face equal int for new die value. All right. And let's go ahead and do this. And let's go in here and we're going to go public void new face. Actually set face. And we're going to go int new face. And we're going to come into here and say this dot face equals new face. This is workable The thing we would have here, though, is we have a problem because we're now allowing us to set this value to anything. So we could set this to a number that's not 1 through 6. So we might want to do some validation in here. So we might want to say in here, if new face is greater than 0 and new face is less than 7, then we'd want to do this so that we give it some parameters that we're allowing this to happen under. Otherwise, we might want to say else this dot face equals 1. So maybe we have a backup that if we didn't have something that was a valid number, we're going to make it a valid number. We're going to make it 1 every time. So this would probably be a good way to do that. So if we come into here then and we say we want to go my die dot set face sub 10, what would we expect to see here? We would expect to see a, when we print it out, we're going to expect to see a 1 in there. So 5, 1, and then it rolled again, but it's a 1, 6, 1, 1, 4, 2, 1. So that's where it was at 2. We rolled it. We're going to set the face to something else. We set it to 10. That's invalid, so we're going to set it to 1. Same here. Now we could set it to 3, and it would always show up as 3 because 3 is a valid number. And now we can always set it to 3. And that third value is always going to be the 3. All right. So that's how we can load the dice and how we can do an accessor and a getter and just the general things about this die class. Can do one more real quick here, and then we'll get into the other example. Let's go ahead and I'm going to add a new Java project. I'll add one called circle class. I'm going to use the project folders as root and finish. All right, there's no folders in there. We didn't need any. Let's go new class, and we're going to say circle class here. And we'll do this and then grab that. All right. This one I'm actually going to go pull the code for because I don't feel like typing all of this in. Okay, so let's go ahead and go into here, and we're going to do that. We'll save this, and then we'll format it properly. So now it's into the new semester's 149 format instead of the old 4 spaces and all that business. So let's take a look at this one, though. We've got this circle class here. It's got one attribute here. It's got a radius, which is a double value here. Then we're going to have a constructor that lets us construct a new circle based on a radius. So it will have a radius that we're passing to it. Then we're going to have a method here for the area of the circle, the circumference of the circle. We're going to get the radius so we can pull that value back, and we're going to be able to set the radius. So these are the methods that we have in here. What that looks like in implementation here is the attribute here. Private attribute is a double, and it's the radius. Then we've got a constructor where we actually call, again, it's very common for you to call a setter method to set the values and initialize the values of certain attributes. Here we only have 1, so we're just going to set the radius to 1. You can also say this dot radius equals radius. That's the other thing you could do. So this would be valid. This dot radius and this looks really obtuse and strange. What this is doing is it's saying this object, I want to set the radius attribute of it to the radius parameter that I'm pulling from inside of this parameter that's being sent. It doesn't help that we're calling all of these radius because this gets very confusing. So you may want to start doing things like new radius, new this, new that, as the parameters you're passing into here. So you could say new radius here, and that would give yourself a little bit more indication that this is something that's coming in that's a new value that we're being passed in. And it's different from the actual radius attribute of the class. So this is sometimes a good best practice so that you do that kind of thing. Again, you can use this new set radius because maybe you want to have again, validation around here. So if this has some validation here, then we're going to be able to do some validation where we don't do the same kind of values where we don't let it be a negative numbers. So if it's greater than 0, we set it to the value. Otherwise, we set it to 0 because we don't want to have negative radiuses in this case. So this would allow us to protect the class a little bit better if we did this. So if we set that and did set radius and passed it new radius here, that would be a way to do that. And so that allows us to do validation even inside of the class constructor itself. So if we create a validating setter, then we can use that, and every object we construct will be a valid object and have valid radius and valid attributes because we did all of our validation inside of our setter. And that's the only way we're manipulating that value of the attribute. So that's something to keep in mind. The rest of these are pretty straightforward. It's just returning. And a lot of these methods are going to be one-liners or two-liners because they're going to be really simple. You can just go return and then return the values of things here, this dot radius, comma 2, and you're just doing pi r squared here for the radius. 2 pi r, 2 pi times the radius. So this dot radius is what we're referring to. We're getting the radius, we're returning this dot radius. These are pretty simple methods, but there are a lot of them. So you can see a lot of the code that we're going to be writing from here on out is code that is very, it's pretty simple as far as the amount and number of lines of code, but the concepts are what you have to get. So the idea of this dot radius and the working with those objects in knowing how to call those objects, knowing how to address those objects. That's going to be the challenge as we move forward into some of these early object-oriented. As you move further, it's just going to be the code as well, because the code is going to get more complex as you work with bigger things. Right now, we're working with simple object classes here that are very standard, only 1 or 2 attributes for each one. So that's going to be pretty simple to work with. All right. That's what I wanted to cover there for the lecture portion. The next piece I wanted to go over was how to look at some tests here and set up tests, JUnit tests inside of Eclipse. Let's go ahead and go with this example here. I think we did this before in JGrasp, but I'm going to go ahead and redo it because I don't know that everybody would have remembered that well. We'll just do this as an example. Do that again. No source files exist. Okay, that's fine. Come into here to this example. We'll do this as file new class. We're going to come in here and we'll call it example.java. We'll do this and this, but we're actually going to pull this from over here. And I will put code over here and save it. This is one from the cigar party piece that was the squirrel. So we're going to make this the soda party just because it's more universally addressable for people who don't have a cigar or smoke. So let's go ahead and go into this example.java. Inside of Eclipse, you don't have to do the association thing for your class and your JUnit test class. So here to create a JUnit test class, all I'm going to have to do here is I'm going to come up into here and go into file, or I can do it from the right click here, new. So I could either come up to here, file new, and then JUnit test case is what I want. Or I can come into here, right click, new, JUnit test case. The test case I'm going to use the Jupyter test. This is JUnit 5. So JUnit 5 is also synonymously known as Project Jupyter. So if you see new JUnit Jupyter test, that's the version 5 of it. So we'll go example test, and we'll do, you could do a lot of your comments and other things in here, set up before class testing, do tear down after the test. These are things you'll get into in 159 and maybe 240. We won't do anything with setup and tear down and before class, that kind of thing. So we're going to come into here though. We're going to test example as the test class that we're going to test. We're going to go next. We want to create tests against this soda party. So maybe we would want to test that method there, soda party. So we can ask task for generated test methods, and we could create final method stubs in there, and these will automatically build some things. It's going to ask us to add the JUnit 5 library to the build path. We want to do that, so we're going to hit OK. And so we can see inside of here, now we've got this example test. We've got this test fail, not yet implemented. So this is how the test gets built over here. And we'll want to change this over to, instead of the JUnit org API here, we'll just do our standard ones over here. We're going to use this import org.junit.assert. And we'll do it this way, same as we've always done. That is a more check style friendly, where we're only using the two classes that we've used before, this assert and the test. So we'll do those assertions. So we create a test here. This is the default test for what we call coverage. We're going to need to make sure we're executing every line of code inside of this example. In order to test the class creation itself, you have to create this test here, a reminder, this new example. So we're going to create this new example here, and that's going to do the testing for that class. To run our test, we come up here to this, and we just hit this run example.java, and we're going to save that resource before we do it. I'm going to hit allow to allow Eclipse to do some network grabbing that it wants to do. We come into here and we see here's the JUnit panel here. It allows us to go in and look at these tests and see what the results of these tests were. We got 3 check marks, so we passed all of those tests. And inside of these tests, I had several different pieces here. Let's go ahead and show you. Let's go ahead and run a coverage test. So to do coverage testing, we see this little green and red bar under the testing. If I click on this, coverage testing allows us to do in JUnit some other extra pieces. We used to actually have to install JUnit into Eclipse and do a bunch of stuff. Now JUnit comes bundled with it, so does this coverage testing, which is great. You don't have to do any more configuration. We don't have to go out and grab those jar files and anything like that. Everything just works. Coverage testing allows us to see how many lines of our code are we actually testing with our tests. I'm going to go ahead and comment out some of these tests for now. And that way we can actually bring them back in and do full what we call coverage testing. And we can see how much of the code is being tested. So right now we're not going to have as much code tested. Let's do a coverage test to see what's being covered. So over here, we can run that coverage test, and we can see here that it's saying 83% of the code that we've got written is being covered by our tests. What this means is that there are portions of code that are not being tested. So if we go into this example.java, we can see in here, it'll start to highlight and it'll show us lines that are tested and not tested. It shows us in green the lines that are tested. So our test that we did with this value of 30 and false, as we passed it to soda party, tested all of these lines here. It didn't check for the weekend because right here we said is weekend is false. And so we haven't ever run this branch of code. We've never come into this test here. So it's yellow because we checked it, but we didn't run successfully through it. So you looked at that line, and it's in yellow, but it still didn't run anything inside of it, which is in red. So in order to test this, we're going to have to create a test that has true. So we do a test down here that is passing a true value in here. If we run our coverage testing now, we go from 73 up to 90%. We've got most of this code tested. We still have this branch here in yellow where sodas is greater than or equal to 40. And then that's still not good there. And then we haven't tested the case where it's outside of this bounds of 40 and 60. So let's go another one here. Let's do 61 in here. And let's do this test here. and add that piece in. So if we add that piece in, now we're testing even more. We still haven't done one. This is greater than 40. So we still need one where we're getting greater than 40. So we've got that 61. We thought we did that, but we're not really getting a full test on that because we still haven't tested every branch in here. So let's go ahead and test another test in here. And let's actually add these two tests to see if we can get full coverage on our test. So we're still not getting full coverage here because we still need something equal to 40, I think is the one that we're missing. So we probably need one here that is set at 40 in order to get our full testing done and our coverage of our testing. Okay. We're going to do that. We're getting down even further because we lost that 39 test in here. Let's go ahead and put one more in here. So this is the process of trying to determine how we can do full coverage for our testing. You're going to have to be writing tests that cover your code so that you know that you're testing every branch of your code. So upper bound is 9999. We're not hitting that one. So we've got the weekend. We need to hit that particular test. So we need an upper bound is higher here. All right, so we need to add in a few more tests in here. I'm not going to go into the full testing to get that one there, quite there. We need to come into here for the good party, and we need to add some of these in. So 70 and 50. Let's go ahead. These were all bad parties, and I keep forgetting that that's what we were doing there. So now that we've added those in, let's go ahead and do the coverage, and now we should be getting back up. And now we are getting, with those two tests here for good parties of 70 and 50, we're now getting full coverage. Everything's green. You don't have to worry about these yellow ones so much, but if you wanted to get rid of those too, you could do some more tests in here, and these would allow you to hopefully get full testing at 100% coverage. So we've got 100% coverage now, and we've got everything but these two still. And I bet these are from 40 equaling 40 and equaling 60 kind of scenarios. We probably don't have as many of those fully covered, so where you can do every branch of those pieces, but you could get rid of those branches too. The big thing we're worried about is lines of code. So we don't care so much about these yellow pieces. You can have the yellow pieces in there. We just don't want to see any red. And so that's the basis of our coverage testing. So you want to be able to get that done so that things are working properly. Let's go into here, and we need to get rid of one of these tests. I think it's a bad one. So, because it is not actually a valid test. Right. Do we need? Oh. Right. All right. Boom. And now we're passing all of our tests, and we've got good tests. And now we have everything passing in all green here. So these were 100% coverage tests. So that is the coverage testing portion of Eclipse. And so I will go ahead and on Thursday, we'll go over some more with testing and the homework chapter 9. Again, don't forget to fill out the word of the day in Canvas. That's the only thing that's due for today. And I would go ahead and get started on chapter 9 homework. You should have enough to get you started with how to do the actual creation of a Java file and then tests. You don't have to use Eclipse. Again, you could do this all in JGrasp. JGrasp does everything but the coverage testing. So, and we're not asking you to do coverage testing. I'm just showing you how to do it here. So you'll have been exposed to how to do it, and you'll understand what it is that it's trying to do, hopefully a little bit better when you cover it more in 159. So I'm going to stop the recording here and